In graph 28.1, we derived the single-peaked preferences for a voter who's voting on the single-dimensional issue of how much of a public good to provide. We'll now illustrate the voting equilibrium if all voters have such single-peaked preferences over a single-dimensional issue. We'll plot the public good level y on the horizontal axis and the utility level attained by a voter on the vertical axis. Recall that we say a voter has single-peaked preferences over the issue y if there is a single most preferred outcome, with utility declining in either direction as we deviate from that outcome. Suppose then that we have 5 voters with such single-peaked preferences, but with different most preferred public good levels. We'll say that the highlighted voter 3 is the median voter, because his most preferred outcome is the median of the 5 most preferred outcomes in this set of voters. The most preferred outcome by the median voter is then the outcome y star m. Now suppose that 2 candidates run for election, each promising to implement a certain level of public good. If one candidate chooses a public good level that lies to the left of y star m, then the other candidate can choose a public good level just to the right of it and be assured of victory. Voter 3, 4, and 5 would vote for the alternative candidate, and the original candidate would only get voters 1 and 2. If a candidate chooses a position to the right of y star m, the same thing will happen. The other candidate can choose a position just to the left of that and get the voters 1, 2, 3, and thus sweep to victory. Any position on the horizontal axis other than y star m can therefore be defeated by majority rule. The only position for which this is not true is the most preferred position of the median voter, y star m. If a candidate chooses that position, then voter 3 will always vote for him if the other candidate chooses a different position. But if the other candidate chooses a position to the left, only voters 1 and 2 will vote for him. And if the candidate chooses a position to the right, only voters 4 and 5 will vote for him, with the other 3 always voting for the first candidate. Thus, the median position will defeat any other position. This is what's referred to as a Condorcet winner, a position that can defeat any other position in pairwise majority rule voting. The median voter theorem then says that if you have an odd number of voters, each with single-peaked preferences over a single-dimensional issue, then the median voter's most preferred outcome will defeat any other outcome in any pairwise majority rule vote.